Sources of electricity. There are so many sources of electricity that are used today. Some include cells and batteries, generators, solar cells or solar panels, thermocouples, and chemical cells. In this subtopic, we are going to look at chemical cells. Chemical cells are named so because they produce an electromotive force as a result of chemical reaction. So they are able to produce electricity through chemical reactions. Chemical cells can be categorized into two: primary chemical cells and the secondary chemical cells. Primary chemical cells. Primary chemical cells are made from metals of different reactivities. Remember, chemical cells produce electricity by means of chemical reaction. So we need two cells in order to construct a simple primary cell. We need two metal plates of different reactivities and an acid. For example, we can use zinc and copper as our metal plates with dilute sulfuric acid. Zinc is more reactive than copper, so the pair is good for a simple chemical cell. So a simple chemical cell, primary cell, can be designed as shown in the diagram. In this diagram, it is observed that bubbles of gas form around the zinc plate. So we have two plates here. Zinc plate is the first one, and then we have the copper plate, and then the dilute sulfuric acid. Then the switch to control the circuit. No bulbs, however, are formed around the copper plate. It is also observed that zinc metal reduces in size or is eaten away as it reacts with acid. Explanation. Zinc is reacting with the acid faster than copper. That is why bubbles are not formed on the zinc plate as they are formed on the copper plate. When the switch is closed, current flows through the circuit, and that can be shown by the ammeter reading. This current may not be sufficiently large to have the bulb brightly lit. The gas that form around the copper plate is found to be hydrogen gas. So we say zinc reacts faster than copper. Ammeter shows the flow of current. Bubbles around copper plate are found to be hydrogen gas on testing. Zinc plate is eaten away as a result of reaction between zinc and the acid. Defects and how to minimize them. We have already said that bubbles accumulate around copper plate. This is known as polarization. Accumulation of bubbles around the copper plate. We have already stated that the bubbles are found to be hydrogen. It is also important to note that copper receives more electrons from the reaction of zinc and the acid, and from this the zinc plate becomes the negative terminal while the copper plate becomes the positive terminal. Copper plate is the positive terminal while zinc plate in this case is the negative terminal. The defect of polarization provides an insulation to the flow of current and also set up some local cells with copper whose electron flow tends to oppose the flow of electrons from the zinc plate. The effect is an increase in internal resistance. So polarization increases the internal resistance. In order to minimize polarization, we add a depolarizer like potassium dichromate or manganese 4 oxide. To minimize, add a depolarizer, e.g. potassium dichromate or manganese 4 oxide. Another defect is local action. The zinc plate, on the other hand, is eaten away as it reacts with dilute sulfuric acid. This is what we call local action. Impurities in zinc promote local action. Local action can be minimized by using pure zinc or coating zinc with mercury. In what we call amalgamation. So you can carry out amalgamation to minimize local action.